Hello, good morning. Is Mike good? Yeah, sounds good. Okay. So how's everyone this afternoon, actually? I said morning. I'm still in weird time zones. How is everyone today? What do you think so far of the conference? Like it? All right, cool. So what I'm going to talk to you today about is PHP and kind of some high-level operations on how it works under the hood. And I got a couple little surprises in here in terms of things you may not know or things you may not want to know, but we'll get to those. So what is PHP really in general? Well, is it easy to use? What do you guys think? Easy to learn? Who here thinks PHP is well designed? Okay, very good, thank you. All right. But is it effective? Can you guys make a living? Can you make good quality products? That's the key. So this is a rather interesting image, and I think it's quite adept because a lot of people are talking about, well, you can't use a hammer to put in screws. If your only tool is a hammer, you'll always look at every problem like a nail, but with PHP, the only thing we have is this weird thing, but okay. So when we're actually dealing with PHP code itself, it's dynamically typed. And what that means is we don't litter our code, and we don't tell PHP the engine what types a variable is going to be or is. We just give it a value. We don't have to worry about it. In languages like C, Java, it's called strong typed, which means you have to give a type to every variable. So PHP tries to abstract that away for you. As we're going to see a little bit later, that is really, really good in a lot of cases, but it's really, really not good in a lot of cases too. But it's also weakly typed. Now, there is a difference between dynamic and weak because this makes sense in PHP. Some people, like me, say this is probably an error. This is you're doing something wrong because 1 plus 1b, what is that supposed to mean? Should this be 2b? I don't know. But anyway, PHP is also implementation defined. Unlike Python, unlike C, C++, and a lot of other languages, there is no specification for PHP. There is no document you can look up and say, how is this function supposed to work? Instead, you have to go to the documentation, which sometimes is right, sometimes is wrong, and the only actual way to know how a function is supposed to work is to look at the source code. Well, there's a number of different implementations of PHP, though. You have CPHP, which is what we all think of as PHP. You have hip-hop, hippie-VM, roadsend, flanger, PHP Compiler. There's at least a dozen others. And finally, there's this little guy down here, which is one that I built probably about 6 months ago or so, which is PHP in PHP, which is generally seen as a horrific idea, including by me, but that doesn't mean it's not interesting, and that doesn't mean it's not fun to talk about. One interesting note here is the quote-unquote reference implementation of PHP actually has this weird recursive property. You need PHP in order to compile and build PHP. A neat little tidbit, but we'll come back and show why. But I just said PHP is compiled. Yes, it is compiled. Despite what you hear, PHP is not an interpreted language. There actually is a separate compiler which compiles out opcodes that run on top of PHP's virtual machine. In practice, there really is a little bit of a difference between interpreted and compiled, but we're going to look through here and see how this actually impacts both PHP's engine and how we interact with it. So basically, the way PHP works, when you need a file, PHP compiles that file and then executes it. So we're not pre-compiling. It's not like Java or C where we have to run a compile step to get something and then run that something. PHP does that inline for us, so we don't have to worry about it. But what I really want you guys to understand at this point right now is there is a distinct compile step. Don't let anyone tell you otherwise. But unfortunately, it happens so fast and so inline that we don't have to worry about it. So let's actually dive in and look at how PHP executes our code. It all starts with this funny-looking naming thing called a SAPI, or a server API. When you start PHP on the command line or in a web server, PHP does not get started. A SAPI gets started. There's a couple different ones. The command line interface, CGI, mod PHP, FPM. There's one for IIS, there's one for Tux, there's basically, I think, around 15 to 20 different server APIs. Think of it this way. PHP is a runtime. All it knows how to do is execute code. But it doesn't know what to execute or what request is coming in. So what it needs is this layer, the SAPI layer, to talk to the web server or to talk to the command line or to talk to wherever the request is coming from and translate it into something PHP's engine understands. So really, you can think of the SAPI as this outer layer, and it's pluggable. So there's different ways we can start the engine and get the request into the engine. So let's talk about the engine a little bit. What happens when we call PHP on the command line? Well, realistically, there's three main phases. And the arrows are a little bit weird here because the SAPI starts the startup, which then hands control back to the SAPI. Whatever. Yeah, it's a little bit wonky. But basically, then the SAPI dictates a request. So if you're on the command line, it starts up and says, all right, I want to execute this file, hands it off to the engine to execute the request, and then the request comes back to the SAPI and says we're done, and then the SAPI can decide what to do from there. Your threaded implementations like mod PHP all happen at this SAPI layer. Each individual request is serial in a single process or in a single thread, and that's what's important to note here. So this line right here is where we basically separate the engine from the request, which also could theoretically allow us to do some really interesting things, like, I don't know, build a SAPI to run PHP code, so now we can simulate multiprocessing and multi-threading from the engine layer. Kind of cool. Kind of useless, but kind of cool. So let's talk about startup for a second. There's really three main phases when we start up the PHP engine. We have to initialize the engine, which basically means allocate a bunch of memory. It has a bunch of global variables that it needs to do. Yes, there's global variables everywhere. It's horrific. So we have to initialize the engine, get the engine working. Then we have to read our PHP INI files and do all that fun jazz, and basically this whole step is a nightmare. But we'll ignore that for a second. Then after the engine is up and running, we have to initialize our extensions. Because PECL extensions like PDO, which exists as an extension, MongoDB's layer, which is a PECL extension, they all get a engine initialization or a module initialization. It's called eminit in PHP. And that happens once per the lifetime of the engine. And once per multiple requests. So it doesn't happen for each request, it's actually shared. And this is what it looks like in C. It's a whole bunch of naming conventions and weird things and common hacks for weird portability issues. Don't worry about this. In PHPPHP, it's a lot simpler. We set up an engine store, a constant store, a class store, an executor, which is basically the virtual machine, and we register the extensions, which basically is the same as calling module in it. So this is really all that's happening. We're taking the engine from the cold state and configuring it and setting up. Now, let's hold off on talking about request for a second and talk about shutdown, because request is where the really interesting stuff happens. Engine shutdown is where everything gets deinitialized, and typically there's not a lot that happens here, but there's some very important things. But additionally, the modules can shut down. So if a module opens a file, it gets a chance to close it. Straightforward. Again, block of code. We're destroying everything we set up in init, we destroy in shutdown. Simple, straightforward, makes sense. And I don't have a shutdown, if you notice, for PHPPHP, because that actually happens in the destructor, and since PHP under the hood takes care of all that for me, I don't have to worry about it, which is nice. So let's talk about the request for a second. You can see here, at the beginning of the request, we initialize it, which basically calls the PECL extensions and say, hey, we have a new request we're going to run. Then we get some code, we compile it, and then we execute some code, and then we compile some code, and we execute code, and we bounce back and forth for a while. And then we go to the request shutdown where we say, you know what, we're going to clean up all the variables, we're going to close the database connections, and the request is over, we're going to send it back to the client. This can happen multiple times in the lifetime of the PHP engine. So if you're using CLI or CGI, that's one request per lifetime. So basically what it looks like is startup, request, run the request, back, and shut down. That's CLI, single request per process. Fast CGI, mod PHP, and a bunch of other APIs, you start up the process once, and then you issue a whole bunch of requests, sometimes in parallel. Sometimes this will fork off for each process. But the point is, startup and shutdown happen once for the lifetime of the engine. This thing happens once per request, and there can be more than one request per engine. So what does that mean? Actually, compilation, it's complicated, but it's interesting. So the way code is compiled in PHP is we first have to lex the code. We take the code and we look at it and we convert it into a series of tokens. In CPHP, we use re2c for that, which then produces this gigantic array of tokens. This is where you get that error that I'm going to try to horrifically pronounce right now, but the T perium nekudatum, whatever, yes, I cannot pronounce things. That's a token. So the parser translates code into a series of tokens. PHP, we use the core tokenizer, token_get_all, and we're actually looking at eventually porting that to a custom PHP implementation. But right now it uses the same parser as the core. And then CPHP generates an array of opcodes, but they're not really opcodes yet. They need to be compiled. PHP, we generate what's known as an abstract syntax tree, which is just a tree of syntax. Again, not overly important, but the interesting thing is, at this step, we are doing two different things. PHP and PHP under the hood, CPHP, we kind of diverge here. And the reason we do that is this bottom method is a lot cleaner, it's a lot easier to build, and it's a lot less performant. So I'm not knocking CPHP for doing it, but there are reasons that we both do it differently. So the language scanner, the lexer, basically looks for this string const as a standalone string and says, okay, return return the constant token. Again, not overly important, but what we're looking at here is we're statically transforming the code into something that C and that the engine can deal with. Then in PHP, basically we call token getAll somewhere in here, and then we get the tokens, and then we parse it. So after the lexer, we need to parse that. We need to somehow turn these array of tokens into something actually meaningful. CPHP, we have these Bison, I'm trying to think of how to describe this really quickly. Basically, definitions of sequence of tokens that actually produce something meaningful. In PHP, we use the AST to do that for us. So this is kind of what the parser looks like in PHP. Gigantic, like OR switch case statement. So we have an arbitrary expression with this ampersand character in the middle, and another expression gives us bitwise and. So basically it's saying this thing here is a virtual group that we're going to call an expression, which includes these potential sequences of tokens, and then we're going to convert it into this type of an opcode. Now the compiler then takes a look at that, runs over it, does a single pass, and optimizes a whole bunch of stuff and converts it actually into something executable. In PHP, it's recursive, whereas CPHP is a single pass. Again, don't worry about the tiny differences. And then finally, we get these funny little things called opcodes at the end. If you ever heard of an opcode cache, that's what is doing this. That's what this is using. And basically what that is, it's an operation code. It has a type, meaning what type of operation needs to be performed, and the inputs and the return value that it needs to go to. So it's just really a series of operations. Now the interesting thing here is your actual CPU has opcodes as well. The only difference is what PHP produces are custom PHP opcodes. So it's the same concept of what C is doing. It's just doing it for PHP's engine instead of doing it for the CPU. So what happens when we actually have actual code? Well, we have A equals 1, B equals 2, and then echo A plus B. Under the hood, PHP transforms it into an operary of this. And if you use, I always screw up the name of this, this code pad, 3v4l.org, I think it is. There's a tab that you paste in code, and then you go to VLD opcodes, and it'll actually show you the operations PHP is parsing your code into. So this says assign the first variable a value of 1, assign the second variable a value of 2, add 1 and 2, and return it into this third temporary variable, and then finally echo it out. Relatively simple. The only reason why you don't see $A and $B here is PHP optimizes that out. It says you're never accessing those variables directly, so we're going to optimize it. But notice something here. We have this transformation that happens. We go from source code through these 3 steps, lex, parse, compile, and we end up with this array of opcodes. So there's something obvious that we're missing here, right? If we look really, really close here, we can cache this stuff. We can cache this transformation and speed up everything, right? Why don't we just build a compiler that pre-compiles everything into opcodes? Makes sense, right? Would make things really, really, really fast. Well, no. It would if the compiler was idempotent, which means that it had no side effects when parsing an individual file. But also that would mean that it would have to make a lot of other assumptions at runtime that we can make at compile time. Basically, what that means is caching of opcodes with the current engine right now is very difficult. There's a lot of code that goes into it and a lot of complexity. And I'll give you an example. When you define a class in a file, and it extends another class from another file, it seems logical that, well, okay, I just compile that class once I get it, right? Well, the problem comes is with an opcode cache, the next request, you may have the same named base class defined differently. So it depends on the state of the engine when you do the compile, how it compiles it. Does this make sense, or is this kind of... No? Okay. Anyway. So, in other words, opcode caching is hard. So, yeah. So let's actually talk about the actual execution here. This is the actual, I'm trying to see, which one is this? This is the main loop that PHP sits in when it actually is running PHP code. Basically, we take the current op line, the current opcode that we have, and we execute it. And then we see what it says. If it says to shut down, then shut down. Basically, it's just a gigantic while loop. And in PHP, this is the exact same code. The only difference is because PHP is not C, we had to do a little bit of extra hackery to get extensions to work. The case here is, this is basically what the executor is doing. It's saying, run the opcode, say, hey, did the opcode tell me to return? No? Okay, run the opcode again. And the opcode, each opcode says, okay, move to the next one, or jump 15, or whatever. But it's basically just a gigantic infinite loop. And then it waits for something else to tell it to leave. But what are we actually executing? What is this mysterious opcode that I've been talking about over and over and over again? We saw some names, but basically we have this add spec var underscore var. So this is basically adding 2 variables together. So we have this whole bunch of bootstrap that's dirty. This is what's generated by PHP. We define this in like a template style language, and then we run PHP code that takes this and that generates this for us. So all we're doing is calling add. Complicated. Messy. In PHP, it's a lot simpler. We have an add opcode that takes 2 variables, op1 and op2, adds them together, and sets it into the result. That's all that this is doing. It's a virtual machine running on top of C. So the last main piece of the puzzle here is we need these things to hold our values, these variables. In C, we have a concept of a ZVal. ZVal is a Zend value. It has 4 main pieces of information. It has something of a value, it has a type, and it has these 2 things called refcount and isref. The type is one of these pieces of information up here, but the point comes is that the ZVal holds whatever type of data that you have, it holds that value. In PHP, we do the exact same thing. And the reason is simple. We care about garbage collection. We care about how we use memory. So PHP uses a concept known as ref counting. Basically, when you copy a variable, you do A equals B. PHP is smart enough not to copy the memory directly. Instead, it says, okay, A points to B, so we increase the ref count to 2. And then now, as we go to modify things, we can then copy on write. Pretty straightforward, but also ridiculously complicated. It counts for, my estimate would be about 40 to 50% of PHP's code base is because of that. But the amount of performance that you gain from it is extreme. The amount of memory usage you save is very significant. So that's really all there is to the engine. We have the simple concept of variables, we have the simple concept of operations, and everything runs together. Yeah, okay. There's a lot more here that I'm kind of glossing over. So let's take a look at that same example from before. A equals 1, B equals 2, and var dump A plus B. Again, this is the opcode that the underlying PHP generates. We assign these two variables, we add them, and then we call var dump, sending as the first parameter the value that we added together. In PHP, we assign, we add, then we initialize a function call, we send the variable, we do the function call, and we return. This entire thing is the var dump of the first object, and I only put this up here because I really want to convey how much these opcodes are tied to the code itself. We have a variable up here that points to the variable named A that it has to look up at runtime. The compiler can't make that determination. And then the other side, op2, which is the variable to set it to, is the value determined at compile time. Assign basically just says, set the return value to the left value to the right value's value. Straightforward. There's a lot of magic happening under the hood. It doesn't really work 100% in PHP. We have to fake a lot of things, and it has to do with the fact of how pointers behave in C versus in PHP. So we assign, then we add those two values together, and all we're doing is get the left one get, the right one get, and then set it into the result. Initialize the function call by name basically says, you want to call var dump. I don't know what function var dump points, the text var dump points to, so I need to go look that up. It goes off, it looks it up, says, okay, I'm going to push this onto a global variable. This is the same way PHP-C works under the hood. Then I'm going to send it an argument or more arguments, which also goes into a global variable. And then I'm going to actually execute that global variable, which then prints out the nice pretty var dump that we see, and everything goes happy. There's a ton more in here. PHP is a partial implementation. We pass about 55 to 60% of the language test cases. There's a lot more to implement. But if you want to look and play around with the virtual machine, that part works well. Variables are lesser of working. Yeah, so we could go deeper, but we don't really have time for that, and it wouldn't really be useful. But if you're interested, get involved. Get involved in PHP, get involved in CPHP, get involved in any of these projects, because open source is good for me, right? Open source is good, right? So for some more information, we have the core PHP on GitHub. PHP doesn't use GitHub internally. They use git.php.net, but GitHub is nice and friendly. lxr.php.net is a great way of browsing PHP's source, the C code behind it, because you can actually click a function name and it'll take you to where it's defined. Something that would be awesome if someone wanted to backport that into like GitHub. And then PHP is on my GitHub. For some reference, if you want to know more about how some of this stuff works under the hood, how arrays and variable types and functions work and everything like that, wiki.php.net has some documentation on it. and I've done a couple blog posts about it on my blog, and as well as Nikita Popov, who's also an internals developer. The two of us have kind of had a series about a year ago talking about some of these concepts. So, thank you very much.